Hello, and welcome to Physics with Wing T.F. McAllister. With me in the studio this evening, oh, excuse me, it's no longer a studio, it's the lecture hall. With me in the lecture hall this evening is none other than Derek Back to Basics Brace. He's right there. Today, I'm going to talk to you about a cloud chamber made with two thermoelectric coolers as opposed to using a box above dry ice or liquid nitrogen. Now, the best thing about this is that anybody can do it. Anybody. It's great for high school students especially because playing with dry ice in LN2 may be a little bit, you may be a little bit uneasy with that, and teachers may not want to give you those materials. It's also great for little kids with dads who happen to be professors of physics. So, the model, which is right here, contains a container that is about half a liter, which is nice, and it's sitting atop two TECs, which is where you see all the wires coming out of, and a huge Kingwin CPU heatsink. So in between the TECs and the container and the heatsink, we have nice layers of Arctic Silver 5, which is the exact same stuff used to build computers if you have ever put a heatsink onto a CPU. So the idea behind a cloud chamber is that you supercool alcohol to the point where it's just ready to form a cloud. I kind of liken it to an undergrad party. It sounds lame, but consider it like this. So the alcohol vapor is supercooled, and it's just chilling there, and it wants to make a cloud, but it needs someone to actually throw the party. And once it has that little seed, it'll form jet-like trails, which are actually particles. Now, another interesting, weird fact about this cloud chamber is that the first one won a Nobel Prize about 100 years ago. So just think of it, we've gone from Nobel Prize winning apparatus to something I can build with parts I can buy on the internet. Pretty badass. So when you have a charged particle move through this vapor cloud, it ionizes the vapor along its track. And that's what serves as the condensation point. So then you get nice poofy jets around that ionized charged track. So you will see, when I tilt the camera up and shine the light, two types of tracks emitted from my radioactive source. You'll see alpha particles, which are helium nuclei, and they look like fat, fuzzy caterpillars. They're really thick, they don't go as far, they're just wide, kind of like sprays. Then you'll also see long, thin trails that stand out as really white objects, and those are electrons. So the thin, long, bright white ones, electrons, or beta radiation, and the short, caterpillar, fuzzy ones, those are alphas. So it's going to take me a little bit because I'm just going to tilt this laptop, and hopefully you'll be able to see some tracks. Sweet! Let's go for a top view. I have no idea if this will actually work, or if you'll be able to see. Holy crap. Derek, would you actually grab my laptop and kind of like tilt it up? Just grab it from the bottom down here and actually lift it up because it's hitting the top. I want it, yeah, kind of like that. So I can see tracks from this angle, so hopefully when I review this tape, everyone will be able to see nice tracks. It's actually a little bit easier if you stare into the light on this one. But right now I see some nice electron trails, and I also see some fat fuzzy alphas. Unfortunately, with this cloud chamber as opposed to one that may be seen from like a liquid nitrogen aspect or dry ice chamber, the saturated volume is really, really small, so you really don't have the opportunity to see cosmic rays, which is a little sad. However, this is a really easy to set up apparatus. It's really fun. High school students, junior high students, probably even middle schoolers could do this. The only hard part is actually getting a radioactive source. So it either needs to be endorsed by a school as like a high school or college level project, or if you're younger, you're going to have to get a teacher to back you up on it. And as always, don't eat your radioactive sources. That's not wise. In the meantime, I'm going to tilt this down, get another view, because I know you can see it from the side as soon as I get the light out of the way. Actually, Derek, could you hit the lights for me too? Let me make it over there. Yeah. And the one up top also. Off. It actually may be a bit easier to see them. Let's see. It'd be hard. It's hard to say if we're seeing anything.
I'm not seeing anything.
Well, on the camera, it's very hard for us to see anything from this angle. And it's also very hard if I actually shine the camera into the light. Because then it just gets whited out. Which is very sad. So from the side seems to work the best.
Yeah.
Yeah, I can see some
Mm-hmm.
on the screen. Well, hopefully this is a cool little side project and you can all enjoy the view. In the meantime, I'm going to send you off in the dark with my favorite catchphrase, and you can't even see me. Oh, there we go. Get the hell off my video file. You goddamn hippies. This is Wing TF McAllister, and you have just left my physics classroom.